We're going to have a look at secondary port height differences now. So where you have a standard port and then a secondary port, and you need to get the main correction for your height differences. And in the sample we're going to look at standard port of Reykjavik, secondary port of Midvagar. We've got the ATT numbers here. And we're going to assume that on the 20th of March for Reykjavik we had a high water of 3.4, low water 0.7. And what we need to do is correct both those two so that we can find the high water and low water for our secondary port of Midvagar. So if we look at Reykjavik on the page there, 819, that's our standard port, and come down to Midvagar, and that's our secondary port. So what we need to do, we need to go along the column Reykjavik towards the end and get our high water springs and neaps values and our low water neaps and springs values. Okay, and make sure that you get them for the standard port that we're talking about here, Reykjavik. Don't use the ones at the top, these values at the top. Make sure you use them alongside your standard ports. So let's look at the high water first. We've got values of 4.0 and 2.9. So that's high water springs and high water neaps, 4.0 and 2.9. For Midvagar, we've got minus 2.3 and minus 1.7. Okay, minus 2.3 and minus 1.7. So we'll write them down here. So for Reykjavik, 4.0 to 2.9, minus 2.3, minus 1.7. So let's just deal with the high water first. We know our high water is 3.4. Now, had our high water been 4, we would simply have subtracted 2.3 off. Had our high water been 2.9, we'd have subtracted 1.7. Well, because it's 3.4, it falls between these two values, therefore our correction must fall between these two values. So if we've got 4 and 2.9, high water springs and neaps, 4 and 2.9, there's our 3.4 value. Midvagar, minus 2.3, minus 1.7. So they were written like this in the book, but what I've done, I've changed the format so that I can perhaps explain the interpolation a bit clearer. So 3.4, our correction must fall between those two values. So when we've worked out our final correction, it must be between those two. And how we do this, we get the difference between 4 and 2.9, which is 1.1. The difference between 2.9 and 3.4, which is 0.5. So we've got 0.5 over 1.1 multiplied by the difference between our two times for Midvagar. So what we're doing, we're finding a proportion of that difference to apply to one of these. Now if you've noticed, I've gone from 2.9 up towards 3.4. For interpolation, you could of course come down from 4 towards 3.4. Because I've gone 2.9 up to 3.4, when I get the proportion of the correction, I must apply it from 1.7 towards 2.3. Had I gone from 4 down to 3.4, I would have had to have applied my correction from minus 2.3 down towards 1.7. So I've got 0.5 over 1.1 times 0.6, which gives me 0.27. So I go from minus 1.7 towards 2.3, and that gives me a correction of minus 1.7. So where I've got 3.4 originally for the day, I apply minus 1.7, so I get a high water of of 2.43. So that's the high water. Low water we do exactly the same, and incidentally it's the same procedure for Pacific ports. So if you can do the interpolation for European, you can do the interpolation also for Pacific. So we get our low water values, 1.3 and 0.2, I've written them here. Our daily amount is 0.7 from the standard port, so once again it falls between these two. So we write down Midvagar's values, 0.9 minus and 0.2 minus. Therefore our correction must again fall between these two values. So our correction is going to be somewhere between those two. Same procedure, 1.3 to 0.2 is 1.1. 0.2 to 0.7 is 0.5. So that would be 0.5 over 1.1 multiplied by the difference between these two, which is 0.7. And that gives us a 0.31. So now we apply the 0.31 from 0.2 towards 0.9. We must go that way. Again, had you interpolated down from top to bottom, you would apply your correction from top to bottom. So our correction now becomes minus 0.51. And as you can see, it falls between those two values. So we write our low water value down, put our correction minus 0.51, and we find our low water is 0.19. Just on another note here, of course, this isn't the only correction when you're going from standard to secondary. You of course have the seasonal corrections, which we haven't discussed here. So you'd have your seasonal correction for your standard port, then this main correction, and then your seasonal correction for your secondary port. And of course you must always remember, with your first seasonal correction for the standard port, you must reverse the sign. Don't forget to reverse the sign. So just to quickly recap, for Reykjavik we pick off these values: high water springs and neaps, low water neaps and springs, get those 4 values. Do the same for your secondary port, get the 4 values, and simply interpolate between them to obtain the high water and low water values required.